Hello everyone, this is Arshi. Today our topic is about linked list. Now let's start our video about linked list. In this video we will discuss about what is a linked list, types of these linked list, operations performed on these linked list, advantages, disadvantages, and last one is applications of linked list. Now what is a linked list? A linked list is a linear data structure in which elements are connected together through a set of pointers. Here the elements are also called as nodes, and we all know about arrays. Arrays will store elements in contiguous memory locations means the size of the array is fixed, but in the linked list it will allow the elements to store in non-contiguous memory locations. Means the size of the linked list is not fixed. Each node will contain two components. One is data and next one is pointer. This pointer is also known as a reference or link. The data which will hold the actual value that is given as input, and next one is pointer. Pointer means it will links the nodes or elements in the list. The first node in the linked list is called head. It is used when it performs traversing. Traversing means displaying the elements and visiting the nodes in the linked list. And the last node refers to null, which will indicate that list is ended. Now types of the linked list. These types will be based on the links in the linked list. These types will be divided in three types: single linked list, double linked list, and last one is circular linked list. Now what is a single linked list? Single linked list is just like a linked list as we discussed before. Single linked list is a linear data structure that is made up of a group of nodes in which each node will have two parts. We discussed about these two parts, that is data and next one is pointer. The pointer will points to the next node. The last node, it is also called as tail, will points to null, which will indicate the end of the list. Here we can see an example of single linked list. Here the elements are connected to one another, and last node will be refers to null. First node is head, and next one is double linked list. A double linked list is bit more a complex than single linked list. Here each node have three parts instead of two parts. Here the parts will be data, pointer to the next pointer, and extra pointer is for previous node. Here the nodes are connected in both the direction, in forward direction and reverse direction. Here the traversal will be in both directions. This will make more versatile. Here we can see an example of double linked list. Here the first node previous pointer is null and the first node is the head. Next will be points to the second node, and the next node previous is points to previous node, and last node next will be null. Next one is circular linked list. It is just like single linked list, but it has some small variation in this circular linked list. That is the last node next will be connected to the first node. Means there is no null in this linked list. Here we can see an example of the circular linked list. The last node next is connected to the first node, means head of the list. Next one is operations on linked list. There are many operations on the linked list, that is insertion, deletion and traversing the list. These insertion can be again divided into three types, that is based on the position of the insertion. First one is insert at beginning. In here a new node is created and it is added at the beginning of the list. And next one is insert at end. Here new node is created and it will be traversed. Here a new node is created and next we will declare a temporary variable and we will traverse the list until the last node, means the node next will be null. We will traverse the temporary variable till next node next is null, and we will add the new node to the end of the list. Next one is insert at a specific position. We will define a position for the insertion and we will update the links adjacent nodes. Next one is deletion. This deletion is also divided into three types based on the positions of the deletion operation. Delete from the beginning, delete from the end and delete at the specific position. From delete from the beginning means first node is deleted from the list. Next one is delete from end. We will traverse the list and we will delete the last node, and at a specific position we will traverse until the till the specific position and we will delete the node and we will update the node. Next one is traversing. There are two types of traversing: forward traverse and reverse traversal. Forward traverse means from starting, means head to next node will be null. In this manner the traversal will be done. In reverse traversal, this reverse traversal is only done in a double linked list, and we will traverse the list from tail to head. Next one is advantages of linked list. There are many advantages of these linked list. Some of them are: linked list are dynamic data structures. They can grow or shrink during the execution of a program. Linked list have efficient memory utilization. Here memory is not pre-allocated. The memory is allocated on during the execution time, and it is deallocated when it is no longer needed. Insertion and deletion operations are easier and effective in this linked list. These linked list provide flexibility in inserting a data item at a specific position and deleting a data from given position. Many complex applications can be made easily. Stacks and queues can be implemented by these linked list. Next one is disadvantage of this linked list. Each node have extra memory for storing a pointer. Linked list do not allow direct access to elements by index. It will need some specific memory for storing a node. Managing pointers is difficult, which increases the complexity of code. The time for searching an element by node in this linked list is about O of n time, which will make some complex somehow difficult, and non-contiguous memory allocation result in more catchy misses. Single linked list do not supports the back traversal in this linked list. Last one is applications of this linked list. These are linked lists are used in data structures to implement stacks, queues, and adjacency list in graphs. It will manages memory, dynamic memory allocation using free blocks, mathematical operations. It is used in long integer arithmetic operations and polynomial manipulations. It is used in compilers, image viewer, web browser, music player, navigate to previous and next items, GPS and robotics, manages routes and robot control systems, undo and redo functionality, represents actions in applications, file systems and simulations, speech recognition and polynomial representation. Thank you.